everything as promised. So as you guys look at the screen and you answer the follow what I said, you're gonna look at my student's work. This is a real student. This is an awesome student. Did wonderful work, except there are some corrections that need to be done to make this better. Okay. You in your notebook, you're going to go through, you're looking at the graph, you're looking at the characteristics that the student wrote. You are going to go through and see if you can identify the things that can make this work, that can just set it to the top. You know, right now it's not quite there. There's some good things, but there's some other corrections that need to be made. And I want to see if you guys can identify those corrections. When you're done identifying the corrections, please type done in the chat, as Miss Bennett does not see you. All right. Don't type your work in the chat. Make sure you're writing it down in your notebook. Thank you. I appreciated that individual who just sent that to me. Thank you. Because I know that you're showing me that you're attentive and you're ready to go. But just make sure you write it down in your notebook, because as you can see, when I load that module in there, you're going to have to turn this in. So you want to have this written down so you can turn it in. Hey guys, I'm taking attendance as well. So I'm seeing done in the chats when you're done, and attendance. Doing that right now because you will be turning this in. So if you didn't write it, you won't have anything to turn in. So give you guys a couple seconds for that. You didn't know Miss Bennett was a soprano. Yeah, we'll get there. We'll get there in a second, Justin. We will get there in a second. You're just running a little bit faster than Miss Bennett. So just giving some people some time. Right, Trinity. You are right to look at that and question that, Trinity. You are absolutely right to not feel comfortable about that. You are right. Keep on going, guys. We'll start in a second. I'll give you a couple more minutes and then we'll start. Okay, and make sure you guys are writing this down too. Some of you are noticing some things and you're like, good work, but this, we can do better. We can do better on this. Yes, some of you are noticing some things. You're, yes, Lazarus. Yes, you're on it. Yep, good stuff. Write that down. Write that down. And Zarin, good stuff. Write that down. Write it down. All right, guys. Thank you all for your patience as we go through this. So let's talk about some of the things that you noticed on my students' work. And as promised, guys, I did go through, I graded your assignments. As you're working, guys, today, I'll go ahead and move your assignments to the categories they're supposed to be. Because some of you may see the grades, but you're like, my grade is exactly the same. Like you did the grading, but it's exactly the same. So Miss Bennett is actually going to categorize your grades for some of the assignments that you did so you can see those adjustments to your grades. But I can tell you that Miss Bennett is 110% happy. Oh, yours looks good. Yours looks categorized already. But I can tell you that I'm 110% happy about what I saw when we started talking about this stuff, okay? When we talked about this stuff, because guys, you all did so well. So if you look back at your grade for this assignment for the guided notes, I gave you guys the grade, but if you look by the comments for this grade, it'll tell you if you need some support. And I told you what the support was. Let's talk about this student here who did a wonderful job. I can tell they really understand growth and decay. They have a partial understanding of the asymptote, but there's some things that we can fix here, guys. Let me know. Someone tell me about the graph. Tell me one thing that you noticed on the physical graph that needs to be adjusted. Did they do well in identifying growth and decay? Was that good? Was that a check? Yeah, I think so. They did great. All right. So the next thing that I want to ask you, what else? What can be adjusted? Drop it in the chat. Yeah, that y-intercept. Where's the y-intercept supposed to be? And I'm not ignoring those individuals who sent it to me. And you're like, hey, Miss Bennett, I sent it to you like 5 times. We're now in class. And do I have it on? Yeah, everybody publicly. Yeah. Yeah, the y-intercept we know should be at 0, 1, but tell me why. Why for every parent function is the y-intercept at 0, 1? Why should it be up here? Explain that to me, guys. And you guys did great in your explanation of this. I was beyond impressed. Some of the explanations you gave. You guys talked about real life applications. You were inspired by my zombie apocalypse. What did you tell me? Case 0 is actually what? Yeah, it's always the first case. Case 0 is our first case, right? So case 0 is going to be our first case. So that it only makes sense, right? That, especially if we're thinking about a zombie apocalypse, it only makes sense that case 0 would be 1. Also, when we think about the rules of exponents, anything we raise to the power of 0, it's going to be 1, right? Anything raised to the 0 power, we will end up with 1, okay? And then Ty says, because you told us that, Miss Bennett. So we're just doing what you told us to do. That's always a good explanation as well. My teacher told me. All right, with that being said, guys, uh, let's look at the range. Is the range good? Is the range good? Give me a yes on the range. Are you guys okay with that? I mean, not the range. I'm sorry, the domain. Is the domain good? Are we okay with the domain on this? Yeah, domain is good. Yeah, domain's great. I think so too. What about the range on this? Yeah, range. Okay, so what should the range be changed to? If the range is not good, what are we thinking? It does seem off, right? Because if we're looking, if this was negative infinity, I mean, it would seem like the graph would be down here, right? We would have some values for y down here. But when we look down here, there are no values. 0, right? So when I go back to this range, I would correct this student's work by saying, hey, the graph goes from 0 to infinity. And guys, this is actually, there was one more thing about the graph that I think needs to be adjusted that I forgot to tell you guys. There's one more thing. Do you guys notice? And the range is an indicator of the one thing missing from this graph that I told you guys to always, always, always sketch. Okay, always sketch it because Desmos is not going to show you this. It's not, but you know this is here. What is the other thing that this student is missing from their graph? Drop it in the chat. Drop it in the chat. Yeah, the asymptote. Okay. So we want to put that asymptote, we want to actually sketch that on our graphs, guys. That's something I noticed. I graded everything, I know, but here's the trick. I did not get to go through everybody's free response. I'm so sorry, guys. I'm gonna get it in there for you all. But I can tell you of the ones that I graded, this was some of the things, not this, no. I'm sorry, wrong test. I'm talking about the quiz. One thing I noticed is you guys, a lot of you did not sketch the asymptotes. A lot of you did not even sketch the holes. Okay, so that's a big deal. You want to have your asymptotes and holes sketched in your graph. Your calculator will not give them to you. So where's the asymptote go? I'm talking to a person who's never known about exponential functions. You tell them the asymptote goes where? On zero. Is it vertical on zero? Horizontal on zero? Horizontal on zero. So let's talk about that. It is a horizontal asymptote on zero. And that means that I want to just skip really quick. I'm going to skip from domain and range or in behavior. I want to go down here to this. Now we've already fixed this. We said this is at 0, 1. We know y-intercept has to be at 0, 1. So we will want to fix that for this friend. But the asymptote, so how do we notate the asymptote? Go ahead and write what should be in that blank. Where is the asymptote? Yeah, y equals 0. Awesome, my good students. Okay, let's go back to this in behavior. Is the in behavior okay? Is it great? Like, is it together? Let's see, on the right side, x goes to negative infinity. Is that okay? If I look to the right, is x going to negative infinity? No. Yeah, if it went to if f of x was going to negative infinity, it'd be like going down to the infinite values. And that's tricky. But just pay attention, guys. When they talk about what the behavior is doing, we're talking about where the graph is actually going. And if I look at that, this graph is not going in the negative land, but look at it. This graph is actually moving closer and closer to 0. Good job, guys, in the chat who are dropping that in the chat. You're on fire. Okay, what about the right side? Right side behavior, is that good? They have it going to infinity. Is that good? Give me a thumbs up. Let me know. Right side behavior, are we good? Yes, yes, yes. Okay, with that being said, guys, this is one thing that you need to take a picture of. Go ahead and upload it in Canvas. And I just have to say, like, I had to do this as a warm up because it really encompassed everything that I saw, in terms of your domain and range and your characteristics, in terms of sketching those asymptote, um, everything, right? The in behavior is 0 for the one side, but it can't, remember, in behavior is both sides of the graph, right? So we got to talk about what's happening on the right side and the left side of the graph. Okay, that's because there's a negative and positive infinity. Okay, I hope this is making sense. So you'll have two different sides that you always describe when you're describing the in behavior. Okay, two different sides when you're describing the in behavior. Okay, so that's why you're going to have right side be 0 and left side be infinity. If you go up to today's module, you're going to submit it underneath where it says transforming exponential functions guided notes. Now, somebody just asked, do I need to resubmit it if I already submitted it on Monday? or on Friday. How did you submit this on Friday? You had this student's you had the student's work and you corrected this student's work on Friday. So so you can't, you couldn't have already submitted this. Yes.
On Friday, you told us to do what we hadn't finished because we didn't have a Zoom call. And then,
Right. That's your guided notes. Before this warm up, you're actually looking at someone's work and you're writing their corrections. Does
okay,
that make sense? So yeah, this is a problem. You are absolutely right. This is a problem from the guided notes, but you're looking at their work and it's almost as if you're giving feedback, right? You're being a teacher and you're saying, hey, nice, but you can do this, you can do that, you can do this, and you can do that. Does that make sense?
yes,
Thank you. And I see what you're saying, but yeah, come submit this as if you were the teacher. Grade in their paper. All right, so where are you submitting it, guys? You're going to hit where it says transforming exponential functions guided notes. Okay. I'm going to bring this over. Oh no, we're already here. We're here. So I am going to close out of this. And so just follow me to your course. Follow me to your course. And you'll hit modules. And come on. Okay. So here's our checklist. And I'm going to go over the checklist for today so we're all on the same page. We're going to talk about transformations of exponential functions. So we're going to do 2 activities. The first thing we did was the warm up for today. And this is where you're going to submit the warm up. The second thing we're going to do, and you'll be uploading this today, is the graphing exponential functions practice. So let me go to the warm up. Today, you're only going to be uploading the warm up, which means you're the teacher, you're Miss B, right? So you graded this student's work. Nice job, such and such. However, here's things that you need to keep in mind. So you grade that student's work. You're going to upload that you did that. Okay. So you're not uploading your problem number 4. No, you're just uploading, hey, as if you were grading this student's paper, the corrections. Okay. Does everyone understand what they're doing for the warm up? Are we all on the same page with that? You are not uploading your guided notes today because look, it says upload your completed guided notes. And today you will not be completing those guided notes. So the guided notes will not be uploaded today. Okay. So I hope that's clarity for everybody. But what's cool is that we already have the guided notes up and we're going to get started on filling out those guided notes today. All right. So go ahead. If you need to print it out, take a second to print it. Ms. Bennett is going to get some info for you all. And give me 1 second, guys, because I completely just lost my, I got so many windows open. Okay, I lost our window, or I lost my window. So just give me 1 moment, guys, and thank you for your patience. And I have too many Google windows open, too many browsers. You're supposed to submit the correction thing by itself. So you are good to go. Yeah, there's no way that you can submit your guided notes right now because the guided notes are not complete. So when you would put your upload for your first submission, it is just this warm up only. Yes. Okay, guys. So by now you have printed or you're just writing this down. Okay, so by now, this is due today. I mean, you should essentially be able to get this is going to be a pretty I can't I don't know. I don't want to say easy, but let's use the word. This should be very simplistic. Okay, this should be a simplistic assignment. So hey, go ahead and fill out your guided notes right now. All right, let's talk about transformations. So you guys are now exponential functions pros. You can see a parent graph and you can sketch it. And Miss Bennett knows you can because I looked at each and every one of your work, and I saw my students, and I was so proud of my students. It's like, look at my students. I'm not there, and they're making me proud. Okay. So I know that you guys have the tools, you grasp the exponential function. So we are going to move and take it a step further. And we're going to talk about these transformations. Look at the transformations to this function. Does this not look like deja vu? We got our A and our H and our K. Look at those shifts. Look at that. This is just all the stuff we know, right? But it's just like a different function. Like, you know, the same story, but a different song. With that being said, let's write about these shifts, guys. Hey, H, we got A times B to the X minus H plus K. H, notice H is just still the same thing. It's what's being subtracted from the X, right? This does the same thing to the function. It's a horizontal shift to our exponential function. If I am adding H, I'm going to shift to the left, and I'm subtracting H, I am shifting to the right. Was someone talking? No one said anything? Okay, good. K. K is the vertical shift. Look at that. Look at that, guys. Look at that. K is the vertical shift, and it does the same thing. If I add K, it's a shift up. If I subtract K, it's a shift down. And look at A. Are we feeling deja vu, fourth period, or are we feeling deja vu? A does the same thing. If the absolute value of A, yeah, this is just like the same stuff. Absolute value of A is greater than one, we're going to have a vertical stretch. If A, the absolute value of A is between 0 and 1, we're going to have a vertical compression. Now listen, guys, say A is negative. What does that negative in front of the A do? Okay. What does the negative in front of the A do? The negative in front of the A. The negative in front of the A is going to do what, guys? Think about it. It's the same song, same story, different song. Yeah, it's going to reflect it over the X axis. Okay. So my negative, if A is negative, now I have a reflection. And I think when we introduced this, I showed you guys an example on Desmos where that happens. I have a reflection over the X axis. What determines if it stretches or shrinks? This guy right here, right? A. If the absolute value of A is greater than 1, it's going to be a vertical stretch. If it's between 0 and 1, we're going to have a vertical compression. Okay. Now, do not worry because let's put this all together. Okay. Let's put this all together and let's practice it with 1 through 4. Okay, let's practice these transformations. All right, guys. So let's look at the first transformations. Does everyone have the notes? You've copied this down, and we're now moving on. Yes, thumbs up. You filled in the blanks. All right, let's do the directions that they have for us here, okay? And I need your undivided class participation. All right. All right, guys, it says A. It says for A, identify the parent function, and B, describe the transformation. Okay, so the first thing we're going to keep in mind when we do this is our transformations. Okay, f of x equals A times B to the x minus h plus k. Okay, so we got to keep that in mind as we go through these transformations. So if I look at number one, right, first I need to identify the parent function. Well, before I do anything, I want to identify what a, h, and k is, and b. Well, if I look, 3 is the base. So 3 is going to be my b value. I do not have a transformation A, or I don't have a transformation H either, okay? But I do have a K transformation. This 5 is my transformation on K. Okay, so now I'm gonna identify the parent function. Well, remember the parent function is f of x equals b to the x. So if I know my b is 3, then I know my parent function has to be f of x equals 3 to the x. I take the base, whatever the base is, and raise it to the x power. Now, for b, I got to describe what transformations they put on number one. And I'm looking at it, the only transformation was our k transformation. So that means that I need to shift the graph up, right? Because it's a plus 5. So I'm shifting the graph up 5 units. I matched my transformation for k to what it does, right? I know that 5 is k, so I match it to what it does. All right, guys, let's do number 2 together, and then I'm going to have you guys work on 3 and 4. Number 2, I'm going to identify what my A, H, and K is. I know A, again, is that number being multiplied by the base. So in this case, A is 2, right? 2 is A. My base is 1/4. Yep, Isabel, you are right. Yep, it's just the base and the power x, not all its powers, because h does not go in our parent function. H is a transformation. Get with me later, Mira, and I'll pop it up for you when I send them off. Thank you for letting me know. All right, guys. So I got my A, I got my A, I got my B, my H, and there's no K this time. So let's go for the first one, the parent function. Well, the parent function is f of x equals b to the x. So this is what I was saying. We don't want to, yeah, it's just the one, Trinity, just the one, not the, yeah, H is just that one. Perfect. But yeah, we don't want to include x minus 1 for the parent function, because that minus 1 is a transformation. So when we write the parent function, it's only the base and its power x, okay? So I'm just taking the base, which I know is 1/4, and I know that would be raised to the x power. That's the parent, okay? 1/4 raised to the x power. Now I'm gonna write the transformation, guys. And I look and I have a of 2. Well, if I look at the transformations, remember what A does. A, if A is greater than 1, A is going to stretch the graph vertically. So a vertical stretch, and I'm gonna just shorthand by a factor of 2, right? And let's look at the next part. Okay. If H is subtracting 1, then the other thing that happens, okay, H is a negative 1. The other thing that happens is that I shift the graph to the right. Okay, so this is a right shift, and I'm just putting a R. I'll do RS, right shift, and it's going to be 1 unit. Now, I want you guys to take a second. I want you to work on 3 and 4. Find the parent function. Tell me what the parent function is, and tell me what the shifts are. All right. Find the parent function. Tell me what the parent functions are, and tell me what the transformations are. Okay. And Mira, I'm gonna go ahead and put up the notes that you missed. Yep, you're absolutely right, baby. You are right.